Students, today I am going to discuss motion in a straight line. We observe different types of objects or bodies around us. Some of them are at rest and some of them are in motion. So the study of motion of objects or bodies is very important to us. In order to describe the motion of an object, we require the knowledge of position, velocity, and acceleration of the object. However, position, velocity, acceleration of an object are different for different observers. For example, consider an object at different distances from different persons. In this case, the positions of the object are different from different persons or observers. Similarly, consider another example. For a passenger sitting in a bus, moving with constant velocity. The velocity of the bus is 0. But for an observer standing on roadside, the moving bus has certain velocity. Thus, we find that position, velocity, and acceleration of a body are relative terms. Therefore, to make the meaningful statement about the motion, velocity, acceleration, etc., these are to be measured with respect to a prefixed point or place. This fixed point or place with respect to which the position, velocity, acceleration, etc. of a body or an object is measured is known as frame of reference. Now, for example, a person standing on a roadside to observe the motion of a moving bus is termed as a frame of reference. Similarly, a passenger sitting in a moving bus to observe the objects outside the bus is another frame of reference. Okay. Now, there are different types of frames of references like Cartesian coordinate system, spherical polar coordinate system, and cylindrical coordinate system. But we shall discuss only the Cartesian coordinate system. Okay. Now in Cartesian coordinate system, we will draw two axes. Suppose this is our x-axis and this is our y-axis. Okay, this O is the origin or reference point. This is the point. Suppose it is P and its coordinate is x comma y. Okay, and if we draw two, which is this, so this is our x and this is our y. Okay, so the position of the object at P is determined by the two coordinates x and y. In a plane, the distances x and y are measured by an observer with respect to O with a meter rod or something like that. Okay, now a Cartesian coordinate system is of two types: inertial frame of reference and non-inertial frame of reference. Now, what is inertial frame of reference? Any frame of reference which is either at rest or moving with uniform velocity is called inertial frame of reference. And Newton's first law of motion is valid in this frame. For example, a train moving on a horizontal track with constant velocity. This is an inertial frame of reference. And a frame of reference fixed in stars This is also inertial frame of reference. So inertial frame of reference is a frame of reference which is either at rest or moving with uniform velocity. Okay. Now what is non-inertial frame of reference? A frame of reference which is accelerated is called non-inertial frame of reference, and Newton's first law of motion is here. For example, a ball lying on the floor of a bus which is at rest. This ball starts moving when the bus is accelerated. Thus the bus in this question is non-inertial or accelerated frame of reference because the bus is not at rest. Okay. And the force which causes the motion in non-inertial frame of reference is known as pseudo force or fictitious force. Okay. And generally rotating reference frames are also non-inertial frames of reference. Clear? Now let's discuss some relevant terms related to this motion in a straight line. The first one is distance. What is distance? Actual path covered by a moving body, and this is a scalar quantity. Okay. Now number 2 is displacement. What is displacement? This is the shortest path covered by a moving body. Suppose point A, point B and point C. A body is moving from A to B, and the path length of AB is 2 meter, and suppose it is 4 meter, BC. So a body is moving from A to B, then B to C. Okay. Therefore distance covered will be the actual path covered. So AB plus BC. That means 2 plus 4, it is 6 meter. What will be the displacement? Displacement is shortest path. What is the shortest path? Shortest path covered between initial and final point. So here initial point is A and final point is C. So the shortest path is just a straight line connecting A and C. So the displacement will be AC. And using Pythagoras theorem, we can write this is 2 square plus 4 square. So it is square root of 4 plus 16. It is root over 20. And it is 2 root 5 meter. And displacement is a vector quantity. I'm sorry. It is a vector quantity. Okay. That means displacement has magnitude as well as direction. Just like in this picture, displacement is 2.5 2 root 5 meter and its direction is from A to C. Okay. Now let's come to next term, that is speed. What is speed? We know speed is equal to distance travelled divided by time taken, and it is of course a scalar quantity. Okay. Now we will study different types of speed. Number 1, uniform speed. Uniform speed. An object is said to be moving with uniform speed if it covers equal distances in equal intervals of time. Just like suppose A, B, this is C, and this is D. And it is 4 meter, 4 meter, 4 meter in 2 seconds, 2 seconds, 2 seconds. So VAB is equal to 4 by 2, it is 2 meter per second. VBC is equal to 4 by 2, it is 2 meter per second. And VCD is equal to also 4 by 2, distance by time, it is 2 meter per second. So these are constant. So the speed is constant throughout the journey of the body. So this speed is said to be uniform. The body is said to be moving with uniform speed. Okay. Now number 2, variable speed. Variable or non-uniform speed. An object is said to be moving with variable speed if it covers unequal distances in equal intervals of time. Okay. Say A, B, C and D. 2 meter in 2 seconds. First 2 meter it has covered first 2 meter in 2 seconds. Next 4 meter in 2 seconds. In next 2 seconds it has covered 6 meter. Therefore, VAB, speed of the body for the first 2 seconds is 2 by 2, it is 1 meter per second. For the next 2 seconds, VBC is equal to 4 by 2, it is 2 meter per second. For the next 2 seconds, VCD is 6 by 2, it is 3 meter per second. So we can see that these three speeds are not equal. So this is not constant. So the speed is variable or non-uniform speed. Okay. Now the next one is average speed. For an object moving with variable speed, average speed is defined as the ratio of total distance travelled by the body divided by total time taken. Okay, this is the formula of average speed. Okay, if a body covers delta x distance in time interval delta t, therefore V average we can write delta x by delta t. Okay, now there are different situations. First situation is body covering different distances in different speeds. Okay, then how will I calculate average speed of the body? Let's see. Suppose a body covers distances S1, S2, S3, with speeds V1, V2, V3, Okay. Now, time taken to cover S1, that is T1 is equal to S1 by V1. Similarly, T2, time taken to cover S2, T2 is equal to S2 by V2. T3 is equal to S3 by V3, and so on. Therefore, V average we can write total distance by total time. So total distance is S1 plus S2 plus S3 plus divided by S1, T1 plus T2 plus T3. So we can write S1 by V1 So we can write V average is equal to S1 plus S2 plus S3 plus divided by T1 plus T2 plus T3 plus This is equal to S1 plus S2 plus S3 plus divided by S1 by V1 plus S2 by V2 plus S3 by V3 plus . So this is our formula. Now if S1 is equal to S2 is equal to S, that is the body covers equal distances with different speeds, then V average will be S plus S divided by S by V1 plus S by V2 is equal to 2S by S into 1 by V1 plus 1 by V2 is equal to 2V1 V2 divided by V1 plus V2. Okay, so V average is equal to 2 V1 V2 divided by V1 plus V2. This is the expression for average velocity when the body covers equal distances with different speeds. Okay. Now come to the next situation. Body moving with different speeds in different time intervals. Okay. Now suppose a body travels with speed V1 in time T1, V2 in time T2, V3 in time T3, and so on. Therefore, the distance covered in time T1, S1 is equal to V1 into T1, S2 is equal to V2 into T2. Similarly, S3 is equal to V3 into T3 and so on. Therefore, V average is equal to total distance covered by total time taken. So we can write S1 plus S2 plus S3 plus dot 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 divided by T1 plus T2 plus T3 plus dot 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 dot, and we can write V1 T1 plus V2 T2 plus V3 T3 plus dot 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 divided by T1 plus T2 plus T3 plus dot 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 dot. This is our expression when a body moving with different speeds and different time intervals. Now if T1 is equal to T2 is equal to T3 is equal to dot 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 is equal to Tn is equal to T say, that is the body covering distances with different speeds in same interval of time. Therefore, V average we can write V1 plus V2 plus V3 plus dot 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 VNT Vn into T divided by NT. This TT cancelled out and we are left with V average is equal to V1 plus V2 plus V3 plus dot 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 plus Vn divided by n. This is the formula, and this is basically the arithmetic mean of all the speeds. Okay. Now come to another type of speed, which is instantaneous speed. Now what is instantaneous speed? When a body is moving with variable speed, then the speed of the body at any particular instant or at a particular point of its path is called the instantaneous speed of the object. The speed at any particular instant of time. The name is instantaneous. That means at any instant of time, the speed of the body is called instantaneous speed. Let a body covers a distance delta x in a small interval of time delta t. Okay. Then average speed will be, we have already learned, delta x by delta t, where delta x by delta t. Now when this delta t tends to 0, suppose this is the point A and this is the point B. When delta t tends to 0, delta t tends to 0 means this point A approaches B. Just like this, just it has become a point where A and B is the same point when delta t tends to 0. So at this particular time, the speed of the body is known as instantaneous speed. Okay? Therefore, V instantaneous is equal to limit delta t tends to 0 delta x by delta t. So instantaneous speed is the limiting value of average speed. Okay, and this is equal to dx dt. This is the formula where dx dt, what is dx dt? Dx dt is the first order derivative of distance with respect to t. Okay, so when a body moves with constant speed, suppose a body is moving with uniform speed, then only when a body is moving with uniform speed, that is at every instant speed of the body is same, then only V average is equal to V instantaneous. Clear? Okay, so this is all about speed. Now come to another term, that is velocity. Now we know the definition of velocity. This is displacement by time. The difference between speed and velocity is their magnitudes are same, but speed is a scalar quantity and this is a vector quantity. That means velocity has a particular direction. Now let's study different types of velocity. Number 1, uniform velocity. A body is said to be moving with uniform velocity if it covers equal distances, equal displacements in equal intervals of time. That is, when a body covers equal distances in equal intervals of time in a specific direction, That is, the body is moving in a straight line here. We can see here in this section velocity is 4 by 2, it is 2 meter per second. The next time interval, it is v is equal to 4 by 2, it is 2 meter per second. And in the next time interval, v is equal to 4 meter by 2 seconds, it is 2 meter per second. So these are same, that is, the body is moving with uniform velocity. It is covering equal distances in equal intervals of time and in a specific direction. Okay. Now, non-uniform or variable velocity. I want to tell you something before starting this. Say if the diagram was like this, and this is also 4 meter. I'm sorry, this will be second. Okay, 4 meter 2 second, 4 meter 2 second, again 4 meter 2 second. Now here also v is equal to 2 meter per second, v is equal to 2 meter per second, and v is equal to 2 meter per second in every intervals. Now what is the difference between these two? Here also the v is same, here also v is same, so it is turning. The difference is here the speed is uniform, magnitudes are equal, but the body is changing its direction at every point. Here its direction is like this, here its direction like this, and here its direction like this along the tangent. So this is uniform speed and this is uniform velocity. Okay. So we can call a velocity as uniform velocity when its magnitude as well as its direction remain fixed, remain constant throughout the journey. Then only its velocity will be called uniform velocity. So the next type is non-uniform velocity. So the next type is non-uniform velocity. A body is said to be moving with non-uniform velocity if it covers equal distance. আমার হচ্ছে না, ভালো লাগছে না, আমার একটুকুও ভালো লাগছে না, সব উল্টো পাল্টা জায়গায় হয়ে যাচ্ছে, দেখতেই পাচ্ছি না, ভীষণ ইরিটেটিং লাগছে আমার। Okay, so the next type is non-uniform velocity or variable velocity. A body is said to be moving with non-uniform velocity if it covers unequal distances, unequal displacements, in equal intervals of time, that is, the speed is constant but it is speed is not constant, but it is moving in a straight line, or moves with constant speed but changing its direction. Okay, so this is non-uniform speed. Now the next is average speed. And average speed, average velocity. For an object moving with variable velocity, average velocity is defined by total displacement divided by total time taken. Okay, suppose this is our this point is O, and this is our reference point. In the time interval t1, its position is x1. In time t2, its position is x2. Okay, first at t1 it was at this point, at t2 it is at this point. Therefore displacement is x2 minus x1, and total time taken is t2 minus t1. This point, suppose this is point A, this is point B. So A is the initial position, B is the final position. So displacement is x2 minus x1 divided by t2 minus t1. So we can write delta x by delta t. If we draw it in plane, then it will be just like this. This is our reference point O. Now our first position of the particle, say it is P, x1, y1. Final position is Q. After time t, it is x2, y2. This is the position vector. OP is the position vector r1. OQ is the position vector r2. So this is our y-axis and this is our x-axis. Therefore, PQ, this will be our displacement vector, which is delta r vector. Okay, and the particle, suppose the particle is moving in this path from P to Q. Okay, therefore the direction of average velocity will be along the direction of displacement vector. This is our B average. Okay, So what will be the expression for this? V average is equal to, we can write delta R by delta T, because delta R is the displacement vector. This is equal to R2 minus R1 divided by delta T. Now R2 is the position vector. So R2 is x2 I cap plus y2 j cap minus R1 x1 I cap plus y1 y1 j cap divided by delta t. So x2 minus x1 by delta t I cap plus y2 minus y1 by delta t j cap. So we can write delta x by delta t I cap plus delta y by delta t j cap. Okay, this is our average velocity in 2D. If we consider three-dimensional motion, then there will be another term delta z by delta t j k cap. Okay, this is our formula, and its direction will be along the direction of displacement vector. Okay, now the next type is instantaneous velocity. This is the velocity at particular instant of time. Okay, now in the previous diagram, suppose in this diagram, if delta t tends to 0, then this point Q approaches P. Okay, for a very small interval delta t, when delta t tends to 0, the Q point approaches P. So we get the limiting value of average velocity, which is instantaneous velocity. Okay, so as delta t tends to 0, V instantaneous is equal to limiting value of V average, that is equal to limit delta t tends to 0 delta x by delta t. We can write like this using vector sign. That is equal to dx dt. This dx and dt are infinitesimal changes in displacement and in time. So this is the first order derivative of displacement with respect to t. So we can write v is equal to, we can denote v instantaneous velocity as only v. V is equal to dx, v vector is equal to dx by dt. Okay. Now in 3D we can write v vector is equal to dr dt, and it will be dx ddt of x I cap plus y j cap plus z k cap. So it will be dx dt I cap plus dy dt j cap plus dz dt k cap. This is our instantaneous velocity. Okay. Now the next term is acceleration. What is acceleration? We know acceleration is equal to change in velocity by time. Okay, here also three types: uniform acceleration, non-uniform acceleration. What is uniform acceleration? When velocity of an object changes by equal amounts in equal intervals of time. And non-uniform acceleration, when velocity of an object changes by unequal amount in equal intervals of time. These are uniform velocity and non-uniform velocity. Now what is average acceleration? Average acceleration is nothing but change in velocity by time taken. If v1 and v2, suppose v1 and v2 are the velocities of an object at times t1 and t2 respectively, then this will be v2 minus v1 divided by t2 minus t1. Or we can write delta v by delta t. In vector notation we can write a average is equal to delta v by delta t. Okay. Now what is instantaneous? Acceleration. This is limiting value of, just like velocity, this is limiting value of a average as delta t tends to 0. That means a is equal to limit delta t tends to 0, delta v delta t is equal to dv dt. Okay. Or we know v is equal to dx dt. So a is equal to ddt of dx dt. So it will be d2x dt2. This is our instantaneous acceleration. Okay. Okay. Now let's solve one example to understand how will we compute average velocity, instantaneous velocity, and average acceleration, instantaneous acceleration, etc. Let's do it. Here the example is the displacement in meter of a particle moving along x-axis is given by x is equal to 18t plus 5t square. Calculate the instantaneous velocity at t is equal to 2 seconds, average velocity between t is equal to 2 seconds and t is equal to 3 seconds, and number 3, instantaneous acceleration. Okay. So, what is given in this question? X is equal to 18t plus 5t square. Now instantaneous velocity. We know instantaneous velocity is equal to dx dt. So we have to differentiate this. x. ddt of 18t plus 5t square. That is equal to 18 plus 5 into 2t. This 18 plus 10t. This is our instantaneous velocity. Now the question is instantaneous velocity at t is equal to 2 seconds. So at t is equal to 2 seconds, v is equal to 18 plus 10 into 2. So 18 plus 20, it is 38 meter per second. This is our answer. This is number 1. Number 2, what is asked? Average velocity between t is equal to 2 seconds and t is equal to 3 seconds. So first we have to find out total displacement. So the initial position at t is equal to 2 seconds, displacement x1 is equal to 18 into 2 plus 5 into 2 square. So it is equal to 56 meter. And at t is equal to 3 seconds, displacement x2 is equal to 18 into 3 plus 5 into 3 square, and it is 99 meter. Therefore, average velocity is equal to, we know, x2 minus x1 divided by t2 minus t1. So here 99 minus 56 divided by 3 minus 2. So it becomes 43 by 1, that is 43 meter per second. This is our average velocity in the time interval. T is equal to 2 seconds and t is equal to 3 seconds. Now number 3, instantaneous acceleration. We know instantaneous acceleration A is equal to dv dt, and we know v is equal to dx dt, so we can write ddt of dx dt. We have already found, so ddt of 18 plus 10t. Here we have already found dx dt is equal to 18 plus 10t. So it becomes 10 on 0 plus 10, it is 10 meter per second square. This is our answer. So in this way, we will calculate average velocity, instantaneous velocity, average acceleration, etc. etc. Okay. Now we will study VT graph for a body moving with uniform acceleration. Here velocity is represented in y-axis and time is represented along x-axis. Now the body is moving with an initial velocity u. After time t1, its velocity becomes v1, and after time t2, its velocity becomes v2, and we get a straight line. Now from this graph we can compute acceleration of the body. How? We know acceleration A is equal to change in velocity by time interval. right? So here, what is the change in velocity? That is v2 minus v1. And change in time, that is t2 minus t1. Here is this is v2 and this is v1. So this BC is v2 minus v1. And here OD is equal to t2 and OE is equal to t1. Therefore, time interval is ED, t2 minus t1. So this is equal to BC divided by AC or ED. So what is this? And if this angle is theta, then BC by AC, that is perpendicular by base. So this is equal to tan theta is equal to slope of the line AB. So this is our acceleration. Therefore, acceleration of a uniformly accelerated motion is equal to the slope of VT graph. Therefore, acceleration is equal to slope of VT graph. Okay. Now we will learn kinematic equations for uniformly accelerated motion from VT graph. First, we will determine velocity attained after time t. Okay, so this is our VT graph for positive acceleration of a particle. U is the initial velocity at t is equal to 0. V is the final velocity after time t. Therefore, OA is equal to CD is equal to U. So OA is equal to CD is equal to U. BC is equal to B minus U and OD is equal to AC is equal to T. Therefore, acceleration is equal to slope of VT graph, we have already learned, is equal to tan theta is equal to, here tan theta is equal to BC by AC. So it is BC by AC. What is BC? B minus U and AC, it is T. Therefore, A is equal to B minus U by T. Or we can write AT is equal to B minus U. Or we can write V is equal to U plus AT. This is our first equation of motion of a particle moving with uniform acceleration. Okay. Now let's do the second equation. What is it? Distance traveled in time interval t. Okay. Now distance traveled in time interval t is denoted by S. Now this S is equal to area under BT graph. Area under BT graph. So see this graph. Here area under BT graph, that means this region, that is area of trapezium OABD. This trapezium, area of this trapezium is equal to distance travelled by the particle in time interval t. And we know area of the trapezium is equal to sum of two parallel sides into perpendicular distance between two parallel sides. Here two parallel sides is OA and BD, and the perpendicular distance is OD or AC. Okay. So this is equal to area of trapezium OABD, that is equal to half into OA plus BD into AC, that is equal to half U plus V into T. We know V is equal to U plus AT. Putting this value here, we get U plus AT into T. So this is equal to half 2UT plus AT square. This is equal to UT plus half A into T square. This is our another equation for a particle moving with uniform acceleration. Okay, therefore S is equal to UT plus half AT square. This is the expression for the distance travelled in time t. This is the equation. Okay, now next, now the next equation we are going to determine velocity attained after traveling a distance S. We know distance travelled is area of trapezium OABD half OA plus BD into AC. So this is equal to half into U plus V into T. We have done it earlier. Now we don't need T. We have to substitute this T using this equation. A is equal to V minus U by T. Therefore T is equal to V minus U by A. So this becomes U plus V, and this is V minus U by T. That is equal to V minus U by A. That is equal to 1 by 2A V square minus U square. This is equal to S. Therefore 2AS is equal to V square minus U square. Therefore V square is equal to U square plus 2AS. This is our third equation of motion. Okay. Now we are going to determine distance traveled in nth second. Okay, so this is our VT graph. Let us consider 2 points A and B on VT graph corresponding to time t is equal to n minus 1 and t is equal to n second. Let at t is equal to n minus 1, velocity of the particle is v n minus 1, and at t is equal to n second, velocity of the particle becomes vn. Okay, and the initial velocity of the particle was u. Now, distance traveled in nth second Sn is equal to, again, area of trapezium A, B, C and D. This is equal to half into sum of two parallel sides. So here parallel sides are AD and BC. AD is equal to Bn minus 1. BC is equal to Bn, and CD is equal to n minus 1. Okay, this is the time interval. So here half into AD plus BC into DC. So this is equal to half into AD is Vn minus 1 plus Vn into DC is n minus 1. So this is equal to half into Vn minus 1 plus Vn into 1. Okay. Now we know that V is equal to U plus AT. Now at T is equal to n minus 1, Vn minus 1 is equal to U plus A into n minus 1. And at T is equal to n second, Vn is equal to U plus A into n. Therefore, S is equal to half Vn minus 1. That means U plus A into n minus 1 plus U plus An into one. This is equal to half U plus N minus A plus U plus N. So this is equal to half 2U plus A into 2N minus 1. Therefore, this is Sn actually. Therefore, Sn is equal to U plus A by 2 2N minus 1. This is our fourth equation of motion, which is distance traveled by a particle in nth second. Okay.